The reading speed of second grade students in a large city is normal with mean 91 WPM and standard deviation 10. What's the probability that a randomly selected student will read more than 97 WPM? Now, when you're asked question about one student, that's what we have been doing in the previous chapter. So that's just, you use this mean of 91 and standard deviation of 10, and you want more than 97. So mean 91, standard deviation 10. In our normal calculator, so stats calculator normal, mean 91, standard deviation 10, and we wanted more than 97 WPM. More than 97, greater than, so 0.2743. 0.2743. And in the second part, they ask what's the probability that a random sample of 10 students has a mean reading rate of more than 97 WPM. So now instead of asking question about one student, they're asking about a sample of 10 students. So now we will use the central limit theorem, and the sample size is, it doesn't have to be greater than 30 because the original population is normal. So you know that when you use central limit theorem, what will now change is the standard deviation. So the sample size was 10. So this new standard deviation would be 10 divided by square root of the sample size. So now it's a coincidence in this problem that the standard deviation, original standard deviation is 10, and the sample size is also 10. But remember, over here, this 10 is the standard deviation, and then the 10 in this square root underneath is the sample size. So everything else was the same, 0.0289. The amounts of time employees in a large corporation work each day are normal with mean 7.5, standard deviation 0.38, random samples of size 24 and 34 from the population, mean from the population, and the mean of each sample is determined. What happens to the mean and standard deviation of the distribution of sample means as the sample size increases? So the mean, so when sample size is 24, the mean is still 7.5. That doesn't matter on the sample size. 7.5 was the original mean. The standard deviation will be the original standard deviation divided by square root of sample size. So divided by square root of 24. So 0.38 divided by square root 24 gives me 0.0776. Oh, two decimal places. So 0.08. And now change the sample size to 34. The mean is still 7.5. And the standard deviation is now 0.38 divided by square root 34. 0.38 divided by square root 34 gives me 0.0652. or 0.07. So what happens to the mean and standard deviation of the sample means as the size of the sample increases? So we know mean stays the same and standard deviation decreases, because you can see first it was 0.08, and then when the sample size increased, the standard deviation decreased. And that has to happen because the sample size happens in the denominator. So if it increases, the standard deviation decreases. So mean stays same and standard deviation decreases.